Let's keep moving with these geometric sequences. This time we're going to focus on recursive geometric sequences. Here's our two learning objectives. I can write recursive formulas for geometric sequences, and I can use recursive formulas to make the first few terms of a geometric sequence. Infinite sequence is a function whose domain is the set of positive integers. All that means it's a sequence, it's a list of numbers that goes on forever. It does not stop. Infinite. Find the first three terms of this sequence. You have an equals 2 times n squared. Well, you just plug in a 1, plug in a 2, plug in a 3, and you find your sequence to 2, 8, 18. This is a finite sequence because it stops. Infinite goes on forever. Finite stops. Sequence is geometric if the ratios of consecutive terms are the same. So you could find that ratio by just dividing second term over first term, third term over second term, fourth term over third term. Basically, whatever term divided by the one that came before it. For this one, dealing with the smallest numbers, 8 divided by 2, you'll see our common ratio is 4. But that same ratio shows up every single time. That's what makes it common. That's what makes it the pattern. Because of that common ratio being the same, 4 every time, we know this is a geometric sequence. The nth term of a geometric sequence we can find using that explicit formula, an equals a1 times r to the n minus 1 power. This is the stuff we just did earlier this week, looking at our explicit geometric sequences. So here's an example, 15, 75, 375, 1875. There's our first term, 15. Find common ratio by dividing. Looks like our common ratio is 5. Notice it's 5 to the first power, 5 to the second, 5 to the third. All it is just repeating that common ratio every time. So we can use that to come up with our explicit formula, 5 to the n minus 1 times our first term, 15. Quick review. Let's try it again just to remember finding terms using explicit formula. This one we want to find the 9th term of this geometric sequence. It goes 7, then 21, then 63. Use the first term, use the common ratio, find the 9th term. If I did so, I would plug in 7 for my first term, I would plug in a 3 for my common ratio, and I'd plug in a 9 for n. So my explicit formula is 7 times 3 to the n minus 1. Plugging in 9 for the 9th term, I get 7 times 3 to the 8th power. Using a calculator, 3 to the 8th power, then times 7. Gets me 7 times 6,561, which is 45,927. So the 9th number on this list is 45,927. All right, enough review. Let's get into the new stuff, looking at recursive formula. Just like how the recursive formula for arithmetic sequences just broke it down with the first term and then what the pattern was, it's going to be the same thing for this one here. Here's the pattern. Remember, arithmetic sequences, we're adding or subtracting the common difference every time. Geometric sequences, we're multiplying or dividing the common ratio every time. So it only makes sense that my pattern is going to be the previous term, a n minus 1, times my common ratio r. Let's take a look at some examples. Find the next term and write the recursive rule. I have 1, 16, 2, 40, 3, 100, 4, 250. Next term is 625. How do I know that? I use the ratio to find the common ratio. And this time it's a weird one. It's 2.5, which I'm just writing as a decimal 2.5. So I multiply 250 by 2.5 and I get the next term, 625. Now I could write it down in my recursive rule. A1 equals 16, my first term. AN equals my common ratio, 2.5, times a n minus 1. Write the recursive rule. It tells you A1 equals 4, R equals 0.02. Ew, weird decimal for the multiplier, but that's okay. Because all we're doing is just plugging it in for our recursive rule. A1 is equal to 4. I have to state that as part of the rule. AN equals 0.2 times AN minus 1. Recursive, guys, it's really supposed to be the simpler one. You need a starting point, and then you need to know how to get to the next step. That's all recursive is, your starting point and how to get to the next step. Let's do another one. Write the first 6 terms of this sequence. You have A1 is equal to 1. AN is equal to 3 times AN minus 1. They're giving you the recursive rule. They want you to find the first 6 terms of this sequence. Remember, recursive gives you a starting point and gives you how to get to the next step. So my first term is just my first term that they tell us. It's 1. Now I use the pattern to find the next one. The pattern is times 3. So 1 times 3 is 3. There's my second term. 3 times 3 makes 9. There's my third term. 9 times 3, 27. There's my fourth term. We're getting bigger now. 27 times 3, 81. There's my fifth term. 1, 2, 3, 4, 5. 81 times 3, 243. There's my sixth term, and that's all I needed for this question. So we saw how to write recursive rules. We saw how to use recursive rules to find a certain number of terms in the sequence. Let's try some of these. Let's practice with some of this. Write the recursive rule for this sequence. You have 16, 40, 100, 250, 625. Find that common ratio, we get 2.5. Find the first term, you get 16. Write that recursive equation. You have A1 equals 16. AN equals 2.5 times AN minus 1. Let's do another one. Write a recursive rule for this sequence. You have 2, 14, 98, 686, 4802. Just like last time, let's find what our first term is. Let's find what the common ratio is. 14 divided by 2 makes 7. So my first term is 2. My common ratio is 7. Use that to come up with your recursive rule. Hopefully you got A1 is equal to 2 and AN equals 7 times AN minus 1. Here's another one. Write the first 5 terms of this sequence. You have A1 is equal to 4, AN is equal to 2 times AN minus 1. Start with your first term, then use the pattern to find the next 4. We want 5 terms here. I'm going to pause for a little bit. You guys figure this one out. All right, so A1's the first one. Times 2 is the pattern. So 4 times 2 makes 8. 8 times 2 makes 16. 16 times 2 makes 32. 32 times 2 makes 64. That's 1, 2, 3, 4, 5. That's all we needed for this list. Oh, man, looks like McGowan has a typo there. Make sure that says 64, not 46 in your list. Don't make the same mistake that I did. But using our recursive formula to come up with our sequence. That's all I got for you guys. Let me know if you have any questions. Good luck.